Thank you. Fascinating talk. And so now we're going to go on to another exciting topic. As we know, Artemis 1 launched successfully over a year ago right now. And we have several Artemis coming up over the next few years. We're going to be landing on the moon, orbiting the moon next, landing on the moon by the end of the decade in the next few years. And to give us an overview of this is Mike Sarafin, who is the Artemis mission manager with the Moon to Mars Program Office. Mike's been at NASA for over 30 years. Prior to his current position, he was the flight director for Orion ISS and Space Shuttle at JSC. So he's had an extraordinary career at NASA over the last 30 years. So ladies and gentlemen, Mike Sarafin.
All right, good morning, folks. Thanks for having me here at the George Washington. I've been asked to talk about the initial tests of the Artemis program, Artemis 1 through 5. So I'll briefly walk you through the capabilities and then the missions that we're going to accomplish and the objectives that we're going to accomplish with those. And that'll take us through the rest of this decade. So with that, if we could cue a video real quick.
It's a new era of pioneers, star sailors, and adventurers.
We're going beyond anywhere we ever went for Apollo.
Splashdown, Orion, back on Earth.
And there's a lot more coming.
Our destiny is always to go and see what's further and what's next.
They're actually metal is being bent, shaped, formed to build the things that we're going to use.
We are going. This is reality.
NASA is at a historic inflection point, poised to begin the most significant series of science and human exploration missions in over a generation.
Astronauts will live and work in deep space, and will develop the science and technology to send the first humans to Mars.
I'm really looking forward to all the science we will conduct on the moon, the samples we'll bring back, the knowledge we'll gain from understanding the lunar environment better than we ever have before.
The more nations and companies at the moon, the more we learn, increasing our capabilities while strengthening things right here on Earth.
We are going to the moon to learn how to live on other planets for the benefit of all. Let's go.
Okay, all right, so let's start with the capabilities on the chart there. We've got quite a bit of capability that is either in production or in the early stages of development. And, just be patient with us as we produce first-time elements here. We've got the Space Launch System rocket, which is uniquely capable of carrying crew and cargo and sending it on to the point of translunar injection in one launch. That's the Space Launch System. We will upgrade that as we go throughout the manifest, and we will have a larger version that we bring on board with our fourth mission with an enhanced upper stage. The Orion spacecraft is capable of carrying crew up out of the Earth's atmosphere as well as returning them back. It's the only element that has an abort system on it if something were to happen during the launch phase, as well as a heat shield to bring our crew home safely. All the other elements are spacefaring, but they don't have the ability to transport crew in and out of the Earth's atmosphere. The human landing system, we have two providers, SpaceX and Blue Origin, with very distinct designs that will take crew after they get to lunar orbit down to the surface of the moon and then back up and sustain them when they're on the surface for roughly a week. I'll combine on this chart the surface operations suits and surface mobility. Once we get down to the surface, we'll perform moonwalks with suits provided by one of two providers, either Axiom or Collins. And then a rover will provide us an extended transport on the surface to extend our our radius from the lander. We'll initially have an unpressurized rover and then have a pressurized rover that will essentially serve as a pressurized laboratory to go around the surface of the moon. In the upper corner, you'll see Gateway. It is a lunar outpost. It will be essentially a station, a space station, a first-time space station in the orbit of the moon that will extend human presence and human stay, initially for up to 30 days. We will build that out through a series of missions, some of which will be launched on uncrewed vehicles, and then other elements will be launched on the Space Launch System with an Orion crew. And then we have a fair amount of ground infrastructure, the space communications and navigation systems that are used to provide command, telemetry, video, and voice so that we can understand the health and status of the spacecraft, provide instructions to it, as well as return video and voice from the crew when they're up there, and then simply to share the missions as they're occurring with all of you. And then the exploration ground systems, that's where the rubber meets the road in terms of assembling and launching all of the Space Launch System and Orion capabilities. And then eventually the Starship will launch out of the Kennedy Space Center off of 39A. We'll launch SLS, or we have launched SLS off of 39B. And then the surface infrastructure, that is additional capabilities that we'll build out over time to enhance our ability to navigate and communicate. So those are the elements. Now I'll walk you through how they're applied to each of the missions. Artemis 1 was our test flight about 1.5 years ago of the uncrewed Orion and the Space Launch System rocket, the first time flight of those elements, and we sent them into a very challenging lunar orbit, and I'll talk more about that here in a minute, but it was a deliberate stress test of the rocket and the spacecraft as well as our ground systems. Artemis 2 is coming next fall, and we've selected our crew. They're in training. I'll introduce the crew members individually here in a few charts. Artemis 3 will go down to the surface of the moon. This will be the first mission that has more than just the Orion spacecraft, the Space Launch System rocket, and the exploration ground systems. We will on-ramp the EVA suits, and we'll on-ramp the human landing system to get down to the surface and then perform science and explore it. We'll go to the lunar South Pole as part of that mission. Artemis 4, we will initially launch a power and propulsion element and a docking node under the initial element of Gateway on an uncrewed mission, and then an enhanced version of the Space Launch System rocket called Block 1B with an enhanced upper stage, a more powerful stage. It has 4 times the thrust and twice the propellant. We'll carry up a contribution by our European Space Agency partners called the International Habitation Module. It'll fly up with Orion and the crew. This International Habitation Module will then be tugged out to the Gateway, and then we'll start assembling Gateway. And then 2 crew members will go down on a lander to the surface of the moon on that mission, while 2 crew members stay on Gateway to activate it. Artemis 4 will on-ramp even more capability. We'll on-ramp the unpressurized rover, and we'll perform a mission via Gateway again, and then down to the surface and extend our science and exploration with the lunar rover. So those are the capabilities and when we're going to on-ramp them, as well as what we've accomplished for the near term. Next chart. We'll talk a little bit about Artemis 1. It was a deliberate stress test of the rocket, the spacecraft. We launched in November of 22 and splashed down 25.5 days later. And we learned quite a bit from that mission, mostly that our systems are performing as we had designed them to, but we also learned a few things where the margins weren't as robust as we would like them to be, and we're working through that prior to our first crewed flight on Artemis 2. But overall, the rocket and the spacecraft accomplished all the objectives, and we purposefully set ourselves up to learn from those objectives. Next chart is a profile that we flew, and you'll notice as we get through each of these missions, the first 3 mission profiles are very different. Artemis 1 was in the Earth-Moon plane, and we launched the rocket, and on the first orbit at Bullet 6 performed a translunar injection maneuver, sent the spacecraft on its way to the moon with precision, and we performed 2 large propulsive maneuvers to enter this orbit. And that is key because we were stressing the propulsion system on the European service module that our European Space Agency partners provided. Through bullets 9 and 10, we entered this lunar distant retrograde orbit. At its farthest point, bullet 11, we were 38,000 miles past the far side of the moon, which was 268,000 miles from Earth. And this orbit purposefully stressed the distance and our ability to navigate and communicate using the Deep Space Network. We needed radiometric tracking to hit with precision bullet 9, which was only about 80 miles from the surface of the moon on the far side. And we pre-programmed that into Orion. It went behind the moon, so we couldn't actually see the maneuver, and we found out after the maneuver was complete whether we were successful or not, and we did it with precision, and then we reversed that 2-maneuver sequence through bullets 12 and 13 to send ourselves on the path back to Earth, and that was essentially our deorbit maneuver at bullet 13 from 250,000 miles away, and we hit the Earth's atmosphere with precision. On the way back, we performed a skip re-entry back into the Earth's atmosphere and splashed down within eyesight of the recovery ship, and we had to relocate due to poor weather in our normal landing site off the coast of San Diego, about 300 miles to the south. We still hit our targeted landing site, and the ship was waiting for it when we got there. So a great mission. We had a few false starts because of technical issues, hydrogen leaks, and some hurricanes, some weather problems, but overall, again, a highly successful mission. Here are some highlight photos. Launch, our flight out past the moon at our farthest point, and then the final moments before splashdown when we got on main parachutes. That's when I finally started to relax. After Artemis 1, we did a robust post-flight assessment. We went through all the systems. What did we learn? What can we do better? Where were the margins not as robust? And that was with an eye towards crew safety. And our Artemis 2 and beyond missions are all crewed. And we wanted to shake down the rocket and the spacecraft, and we did that. So now we're headed towards the first flight of 4 crew members and the first mission with the full-up crew systems. That is everything from the toilet to the food warmer to the water system to the life support system that scrubs out carbon dioxide and removes water vapor and condensate from the cabin. On that first orbit, on the first orbit here, it's a 24-hour period orbit, and it's purposely set up so that we insert into this highly elliptical orbit to allow a full stress test of the life support system. So we're going to see crew members exercise back to back to back with the highest metabolic rate. They're going to have the highest amount of carbon dioxide and the highest amount of water vapor. They're going to expel that into the cabin environment, and then they're going to sleep after that on the first day of the mission, and we're going to see the lowest metabolic rate. So we're going to see the extremes on the life support system, and at the end of that 24-hour orbit at bullet 9, if all the systems check out and we're happy with the performance in the flight environment, we're doing a lot of testing on the ground, but after we see it in the flight environment, if we're happy with the performance, we'll perform what's essentially a mission continuation burn at bullet 9, which will then send Orion using its service module on a free return trajectory about the moon. At its farthest point at bullet 11, we'll be about 4,000 miles past the far side of the moon. That'll be the farthest humans have ever flown before returning back to Earth and splashing down in the Pacific. About a 10-and-a-half-day mission. Next chart, please. This is our crew, starting with Jeremy Hansen. He'll be the first international first non-American to fly to the moon and back. He is an F-18 pilot with the Canadian Air Force. And after him is Reed Wiseman. He'll command the mission. He's a Navy test pilot and was the chief astronaut. Victor Glover is the pilot, also a Navy test pilot. He'll be the pilot on Artemis 2. And then Christina Koch is a mission specialist. She'll be the flight engineer on the mission, and she has the record for the longest stay in one mission of any American woman, and she will fly again as the mission specialist on this flight. In terms of progress, be patient with us. We are building the rocket, building the spacecraft, and upgrading the ground systems for the very first time. There's a lot of work that goes behind these missions as we get there, everything from just training the crew that you see in the upper corner to fly things like the proximity operations demonstration, where they're going to fly and manually pilot Orion relative to the upper stage, just to learn about the handling qualities should we need to go from an automated approach and docking to a manual human-in-the-loop approach and docking, to just producing the next rocket, the next spacecraft. And then we're also upgrading a lot of the systems for what we call human rating. And as part of human rating, we have to add emergency egress paths for any portion of the mission. And in the upper corner on the left, you see the emergency egress system, or the slide baskets from the mobile launch tower. And if the rocket and the spacecraft are not performing and we have a hazardous condition and the crew can get out in a timely fashion, they'll hop in one of these slide baskets and then come down over 300 feet down to the surface of the launch pad perimeter to get out of there. And then we are also training the recovery phase out of Naval Base San Diego with our U.S. Navy partners. The crew was out there this spring and trained basically the post-splashdown and recovery to climb out of the capsule. So a lot of activities going on. When you see these missions occur, they look fairly smooth, but it's because a lot of work, a lot of testing, a lot of training, a lot of planning went into them. Artemis 3, this is our first mission to the surface of the moon in over 50 years. It will be the first mission where humans go to the lunar South Pole vicinity, and it has some unique scientific potential. We want to understand that area better. We've sent robotic precursors to either orbit the moon, or ourselves and other nations have sent robotic precursors to various portions of the moon, but this is a largely unexplored area. And we want to understand what resources may be there to help utilize and leverage in the future. It will also be the first mission, as I mentioned earlier, of the human landing system that will transport us after we send a crew on Orion to lunar orbit. They'll go down to the surface, as well as the first mission with suits. It'll be the last mission with what is called the Block 1, or the less powerful 70 metric ton version of the Space Launch System. Next chart. This is the Artemis 3 mission profile. Now you see, again, a very different mission profile. We will use this mission profile starting with Artemis 3 and on. The profile is literally leaving the Earth-Moon plane. So you got the Earth rotating on its axis and the Moon going about it, and we're going to literally leave the Earth-Moon plane and go 90 degrees out of plane and enter what I think is terribly named the near rectilinear halo orbit. It just rolls off the tongue. So from here on, I'll call it the gateway orbit, because starting with Artemis 4, gateway will be there on every mission. But the crew will launch on the Space Launch System in Orion, and after one orbit, we'll perform the translunar injection maneuver. They'll head outbound. And after the better part of a week, they'll rendezvous and meet up with the lander in the gateway orbit. After performing bullets 7 and 8 to do a lunar gravity assist and fly by and leave the Earth-Moon plane, they'll phase and catch up with the human landing system. They'll dock. 2 crew members will transit over into the human landing system, activate it, check it out, and then through bullets 10, 11, and 12, they'll undock from Orion. 2 crew members will stay in that lunar orbit, and then 2 crew members in the human landing system will then transfer through low lunar orbit and then down to the lunar South Pole and land at one of several sites, depending on the day or the month that we go, on bullet 12. They'll stay on the surface for about 6 days and then reverse that profile and head back up through bullets 14 and 15 to rendezvous with the 2 crew members on Orion. They will transfer back across the hatch into Orion, transfer the samples that they obtained through a surface geology campaign, as well as some scientific experiments that we have, back into Orion. And then at bullets 16 and 17, Orion will undock and then head back to Earth and then splash down in the Pacific again. And we'll pick our crew as well as our science samples from the lunar South Pole up. Progress towards Artemis 3, again, is ongoing. We have multiple missions and multiple capabilities being developed in parallel. Here you see some examples in the neutral buoyancy lab of some of the suit tests and the suit checkouts. We have a simulated lunar surface at the bottom of the pool, and we're checking out tools as well as techniques, and then the suits themselves. We're building the rocket, we're building the spacecraft, and then our partners at SpaceX are testing Starship. They've completed 3 flight tests. They're coming up on their 4th this spring, and they're maturing the design and capabilities of Starship out of Boca Chica. Next chart is Artemis 4. This will be the first mission with the upgraded Space Launch System rocket using the enhanced upper stage. We'll fly a ESA contribution, the European Space Agency contribution, called the International Habitation Module. We'll launch that and the crew together on the upgraded Space Launch System rocket, send them on one shot to the moon at the point of translunar injection. They will meet up with the habitation and logistics outpost, as well as a power and propulsion element that will be launched on an uncrewed vehicle and staged in the gateway orbit. And after that checks out, we'll launch the crew with the habitation module. They'll tug it out to the moon and then start assembling Gateway, and then in parallel with that, go down to the surface. So the first flight of Gateway, first flight of a new contribution to Gateway through our European partners, as well as use of a upgraded mobile launcher called Mobile Launcher 2 out at the Kennedy Space Center, and then the upgraded rocket, as I mentioned. Next chart, please. This is the mission profile. You'll start seeing the pattern here. The Gateway orbit is going to be a pattern that you see for Artemis 3, 4, and 5. We'll launch the crew as well as the HAB module. They'll head outbound. They'll leave the Earth-Moon plane. They'll meet the halo and power and propulsion element in lunar orbit. They'll rendezvous with it through bullets 8 and 9. They'll dock Orion in the HAB module. 2 crew members will go over to the lander, and then they'll undock the lander at bullets 13, 14, and 15. They'll head down to the lunar surface, stay there for about a week and a half, come back up. The other 2 crew members in the meantime are doing work on Gateway. And then through bullets 17 and 18, the crew members will return back up to the Orion and Gateway complex in the Gateway orbit, and then they'll rendezvous and dock, transfer any scientific samples back across the hatch, and then all 4 crew members will come back to Earth through bullets 19 and 20 and then splash down in the Pacific. Next, this is progress towards Artemis 4. You can see assembly and construction of the mobile launcher, a much larger and taller structure than the current mobile launcher. It's over 40 feet taller than the current mobile launcher because that upper stage is bigger. And you can see some of the payload adapters and stage adapters and fairings here, as well as elements of the International Habitation Module, and then of the Orion spacecraft, and then the Space Launch System rocket. Next chart, please. Artemis 5 is the last mission I'll talk about. And again, these missions will take us through this decade to accomplish, but it'll be the first one with a lunar terrain rover. We'll extend our scientific footprint out on the surface of the moon, and we will take a human landing system after the crew arrives on Orion via Gateway and go down to the surface, and we'll check out some of the new capabilities. And then on the next chart, which I think is a progress slide, we've partnered with 3 providers to provide what is essentially a initial concept and design of the rover. That was recently announced, and then we'll down select at some point in the future as to which rover to use as the designs mature. The spacecraft and a number of other systems associated with the landers, as well as the rocket itself, are all in production. And again, we're continuing to make progress in the background as we get ready for these flights. Next chart. So that was it for me. Thank you for your time and attention. I'm happy to take any questions in the time remaining. Okay. See, there were a couple of questions back here, and then we can come down front.
My question was, what do you think is the biggest challenge for, I know this, you talked about up to Artemis 5, but Orion is going to be reused eventually after 3, 4, and 5. What do you think is the biggest challenge for reusability for Orion going forward?
What do I think the biggest challenge for reusability for Orion moving forward? It is going to be simply our ability to turn it around in the time necessary. And we do have plans to use Artemis 3 flown components on Artemis 6, 4 on 7, 5 on 8. There's still time and effort required to get the flown avionics off, requalify them for another flight, and then reinstall them. And it's quite a bit of work, and you got to do that. These are high precision avionics, so it's just going to take time to do it. So it'll be how efficient and how quickly can we do it. We got to get this stuff right. Human lives are relying on it. So, it'll be the first time we have what we call heavy reuse of Orion components. So it's just something that we're going to have a learning curve on. Good question. Other questions? Yes, sir.
When are you planning to introduce optical comm?
When are we planning to introduce optical comm? So on Artemis 2, we have a demonstration of optical communications. It is going to be on the service module, and we'll demonstrate that at lunar distances. It is a demonstration because, unfortunately, the service module is jettisoned prior to reentry. It is not a reused component. So we're looking at other opportunities on where to apply optical communications. Obviously, the bandwidth that it affords exceeds anything else from a standard radio frequency capability. But right now, that's the only plan that we have on the books for optical comm. We had a couple other questions back here. Yes, sir.
So looking at Artemis 4, that is the sustaining HLS contract that will be flown with the Starship HLS lander.
Yes, Artemis 4 is using the sustaining version of the human landing system. Okay, another question back here.
Artemis 4 and 5 crew would be staying on Gateway. Are there any other plans to send people to Gateway for longer term missions?
We are looking at extending the missions beyond 30 days on future missions. We don't have any firm plans for that right now. It really comes down to the test program and what does the test program tell us, and when can we on-ramp extended missions beyond that. But theoretically, we could do in the 40 to 60-day range, but it really depends on how do the systems perform.
You said Artemis 2 and Artemis 3 are going to be crewed missions where Artemis 2 is the orbit, Artemis 3 is the lander. Is there going to be any demonstration, an uncrewed demonstration of the landing system prior to Artemis 3?
Yeah, great question. There are test milestones that we have for all of the human landing system providers. They are required to demonstrate an uncrewed landing prior to a crewed landing, whether that's for SpaceX or Blue Origin. So right now, for the Starship, the uncrewed landing is in, I gotta remember here, it's either the fall of 25 or spring of 26 is when that's the time frame. Prior to that, we have other testing that's going on that will not only help mature the design, whether it's on the ground or in flight, but just inform our overall ability and readiness to fly crew. Other questions over here?
What's the current timeline for Artemis 2 through 5?
Current timeline for Artemis 2 through 5. So we are looking at the fall of 25 for an Artemis 2 launch, fall of 26 for an Artemis 3 launch, fall of 28 for an Artemis 4 launch, and then we hope to go to annual flights after that. There's a little bit of a gap between Artemis 3 and 4 to on-ramp the mobile launcher and the upgraded rocket. Other questions? Okay, thank you for your time and attention. It's an honor to be here. I appreciate your time.